Theorems involving triangle are significant in solving problems related to it and even in higher mathematics. We must understand how these theorems are being constructed or derived and how can we apply them in solving related problems. In this video, we will be discussing triangle inequality theorems such as the exterior angle theorem, theorems that involve the sides and angles of a triangle, and even the Hinge theorem. If you are new to this channel, kindly hit the subscribe button and notification bell so that I'll be able to journey with you in learning math lessons and concepts in an easy way. Triangle Inequality Theorems. After watching this video, you will be able to illustrate theorems on triangle inequalities such as exterior angle inequality theorem, triangle inequality theorem, and the Hinge theorem. Apply theorems on triangle inequalities and prove inequalities in a triangle. Exterior angle inequality theorem. These are the key terms in this theorem. First, we have to know the interior angles, what is an exterior angles, and the remote interior angles. So let's illustrate this one in the given triangle. So this is angle 1, angle 2, and angle 3. So these three angles are called the interior angles of the triangle. So interior angles of the triangle are the angles inside the triangle. Exterior angle of a triangle. Basically, from the word exterior, these are angles that can be found outside the triangle. But not all angles can be found outside the triangle are classified as exterior angle. Only when one side of the triangle is being extended, the angle formed is the exterior angle of a triangle. Exterior angle are angles forming a linear pair with one of the interior angles of the triangle. So if you extend this side here, so you can have this exterior angle. So if you extend this side also, you can have the exterior angle here. If you extend this side going to the left, so you can have this exterior angle here. Now suppose we have a segment that will be drawn outside here. So basically, this is angle 4. So since this angle is not forming a linear pair with angle 3, so this angle is not considered an exterior angle. From the exterior angle, this angle 3 is called the adjacent angle. So we all knew that adjacent angles, these are two angles sharing common side. So this side is common to these two angles 3 and 4. So these two angles, angle 1 and angle 2, are called the remote interior angles. And remote interior angles are angles not adjacent to the exterior angle. Now let's derive the exterior angle theorem. In the same triangle, suppose the measure of angle 1 is 50 degrees, the measure of angle 2 is 100 degrees. We are asked to find the following. First, the measure of angle 3. Second, the measure of our exterior angle, which is angle 4. And lastly, what is the relationship between the measures of the exterior angle to the measures of the remote interior angles? Now, we all knew if this is 50 and this is 100, we all knew that the sum of the three angles of any triangle is always 180 degrees. So therefore, if this is 50 and this is 100, the measure of angle 3 must be 30 degrees. Again, angle 3 and angle 4 are forming a linear pair. So linear pair, that is supplementary. That means that the measures of the sum of their measures is equal to 180 degrees also. So if this is 30, 180 minus 30, so this is 150 degrees. Now, what is the relationship between the measures of the two remote interior angles, the 50 degrees and 100 degrees, to the measures of the exterior angle? Out from this observation, we can come up with a theorem that the measure of the exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So basically, to get the measures of the exterior angle, you just add up the two remote interior angles. Now let's have example number 1. Find the value of x of the following figures. For letter A, so we all knew that the x here is the exterior angle, and based from the theorem, the measure of this angle is just the total of the measures of the two remote interior angles. to solve for x, we just add 50 and 70. So 70 plus 50, that is equal to 120 degrees. For letter B, the exterior angle here from this illustration is given, which is 115. And we all knew if you add these two angles, the sum must be 115. So what must be the value of x? We just subtract 115 by 50 to get the value of x. So the value is 65 degrees. For letter C, so the measure of this angle, which is the exterior angle, is equal to the measures of these two remote interior angles. So in this case, we can have the equation that is 4x plus 2 plus 30 equals 8 plus 6x. Simplify. This is by addition property of equality. We can move 4x to the right side and the sign it will change. So this is 6x minus 4x. So 2 plus 30 is 32. Move positive 8 to the left. So that would be negative 8. 32 minus 8 is 24. 6x minus 4x is 2x. Divide both sides by 2 to solve for x. So our x is equal to 12. So knowing that the value of x is equal to 12, so what if we are asked what is the value of angle Q? So the measure of angle Q would be, substitute the value of x here, so that would be 4 times 12 plus 2 is 50. So for the exterior angle, it measures 8 plus 6 times 12, the value of x, so that is equal to 72 plus 8, so that is 80. So indeed, as you can see, the measures of this angle, which is 80 degrees, is really the sum of these two measures. So 30 plus 50 is equal to 80. Suppose we have this measuring device, this is ruler, to measure the length of these segments. So this segment measures 3 centimeters. This blue segment measures 5 centimeters. The red one measures 10 centimeters. If we will use these sides to form a triangle, so the longest side, second side, the medium side, that measures 5 centimeters, and the smallest side, which is 3 centimeters. So basically, in this case, we cannot make a triangle because from a definition, triangle is a polygon, and polygon is a closed plane figure, and this figure is not closed. So triangle, it is a polygon with 3 sides and 3 angles. So in this case, these sides cannot make a triangle. So how about in these measures? So our shortest side is 4 centimeters. The second side is 7 centimeters. And still, the longest side is 10 centimeters. So this is the longest side. The second side, 7 centimeters. And our smallest side is 4 centimeters. As you can see, this length of the sides can form a or make a triangle. Third illustration, if you have this length, which is 4 centimeters, the second side is 6 centimeters, and the longest side is 10 centimeters. So let's try to make a triangle out from this length. So basically, if you add up two smaller sides, the sum is equal to 10 centimeters. So 10 centimeters is basically is just the same as the longest side. So it will not make a triangle still because it is just a line. So this length of sides cannot make a triangle. So what can you infer from those three illustrations? So if this is the triangle, and this is the length of the sides is represented by A, and this side is B, and this is C. So the sum of the length of any two sides of a triangle is always greater than the length of the third side. So that would be another triangle inequality theorem. So in symbol, so if you add A plus B, it must be greater than C. If you add A plus C, it should be greater than B. Or if you add B and C, it should be greater than A. So these conditions must be satisfied in any of the triangle. Example number 2. State if the three numbers can be measures of the sides of a triangle. So, based from the theorem, if you add the two sides, it must be greater than the third side. So that we will not be comparing 3 times. What we are going to do to determine if these three numbers can be sides of the triangle, we will add up the two smaller numbers. And let's compare that one to the largest number. So if the sum is greater than the largest, so definitely the numbers can make a triangle. So in this case, we will add 5 and 4, and the sum is equal to 9, and that is greater than 7. So these numbers can be sides of the triangle. Or letter B, two smaller numbers, 3 and 2. 3 plus 2 is equal to 5. 5 is less than 6. These numbers cannot be the sides of the triangle. Letter C, 4, 9, 12. So if you add up 4 and 9, so that is 13, and 13 is greater than 12, so this is possible. How about letter D? If you add up, that is 10, and 10 is not greater than 10 because they are equal. These numbers cannot be possible to be sides of the triangle. And lastly, we have 3 plus 9, so that is 12. 12 is greater than 11, so these three numbers can be lengths of the sides of the triangle. Example number 3, two sides of the triangle have the following measures. So we'll now be finding the range of the possible measures of the third side. So these are the two given sides. So for problem number 1, so since this is possible measures of the number, so we'll represent this one into compound inequality. So how do we do it? So what you're going to do, to have the lower boundary, you just subtract the two numbers. So 9 minus 5, so that is 4. So this could be our boundary. So all numbers the numbers greater than 4 could be a possible value of x. But not all numbers greater than 4 could be the measures of the third side. So how do you get the upper boundary? You will add up the two given numbers. So 9 plus 5 is 14. So the upper boundary is 14 and the lower boundary is 4. 4 and 14 are not part of the solution. In the number line, so these are the possible values of x. So to the right of 4, but to the left of 14. So the possible value of the side that triangle inequality theorem will be satisfied are the numbers can be found in this interval. Now for letter B, so 12 minus 4, the lower boundary is 8. So x should be greater than 8, but less than 2, the sum of these two numbers, 16. So this could be the range. For the letter C, 10 minus 3 is 7. So that would be our lower boundary. So our x should be greater than 7, but our x should be less than the sum of 3 and 10, that is 13. Suppose we are finding the length of the sides of this triangle and the measures of its angle. To measure the length, we need the ruler. To measure the angle, we need a protractor. This angle, based from this protractor, so approximately this is 38 degrees. Using the same protractor, this angle measures 117 degrees. And the sum of the measures of this angle is 180. So 180 minus 117 minus 38, so that is 25 degree. Or using the same protractor, you can find the measure of this angle as 25 degrees. So the measure of this length of the side is 8.5 centimeters. So using the same ruler, so this is 3.6 centimeters and this is 7 centimeters. Another triangle inequality theorem. So what have you noticed to the relationship of the sides and the angles of the triangle? So based from the given measures of the angles, the largest angle is 117, the smallest angle is 25. The opposite side of 117 is 8.5. The opposite side of 25 is 3.6. So basically, from this illustration, we can come up a theorem such that the side opposite to the largest angle of a triangle is the longest side. So 117 is the largest, so definitely the side opposite to that angle is the longest. So this is 8.5. Or the side opposite to the smallest angle is the shortest side. Now we can have the converse. The angle opposite to the longest side is the largest angle, and the angle opposite to the shortest side is the smallest angle. Example number 4, arrange the sides or angles of each triangle in descending order. So descending order means We are arranging from greatest to least. So in this case, the sides are given. So this is 12 units, this is 15 units, and this is 22 units. So we're arranging the angles in descending order. So what we are going to write first is the greatest. So based from the theorem, the angle opposite to the longest side is the largest angle. So therefore, our first angle is angle I, the opposite of 22 units, and followed by the angle H, the opposite of 15 units, and lastly, angle G, the opposite of 12 units. Letter B, only two angles are given. So we cannot arrange the side unless we will know what is the measure of the third angle. So this is 65, this is 50, and we all knew if you add the three angles, the sum is 180. So therefore, the measure of angle Z can be solved by 180 minus 65 minus 55. And that is 60 degrees. Since you already have the three angles, so the longest side is the side opposite to the largest angle. And that is XZ. Followed by YX or XY. And lastly, YZ, opposite of the smallest angle. Now, I think you are familiar with this equipment or device. So this can be found at the door, and we call it as the hinges. So the hinges will hold the panel door. Opening of the door will be determined as to the hinges that we are putting into. So in this case, we can measure the opening. Suppose in these hinges, of course, these lengths are equal. So we can determine the opening. So this idea can be best illustrated also in our next theorem, which is the Hinge Theorem. Now suppose we have this length of the sides of the triangle. So this side is 4 centimeters. This side is 6 centimeters. Now we will make use of the same sides in making two triangles. So this is 4 and this is 6 centimeters. The same as 4 centimeters and 6 centimeters. They only differ to the angle or the opening of their angle. So in the first figure, the angle is approximately around 33 degrees. This angle here form is 50 degrees. Now, how long is the third side? So this length, using the same measuring device, the length of the third side, if you connect to make a triangle, this measures 3.3 centimeters. While the other one measures 4.5 centimeters. Or this illustration represents the Hinge Theorem. So Hinge Theorem, if the two sides of a triangle are congruent and the included angle is different, then the angle that is larger is opposite to the longer side. So basically, the larger angle is 50 compared to 33. So side opposite to 50 degrees angle, definitely the longer side. So example number 5. So triangle GHI and triangle NOP. So given the triangle side GH is congruent to side ON and GI is congruent to OP, so which triangle has the larger included angle? Angle HGI or angle NOP? So let's have this illustration for us to visualize the problem. The measure of this side is 15 units. This side is 10 units. So these two sides are congruent. So what is asked is the angle which is greater, the angle HGI or angle NOP. This side is greater to the measure of this side, so definitely the side opposite to it according to the Hinge Theorem is the greater. So in this case, angle HGI is greater to angle NOP. Example number 6, consider the triangle ABC is an isosceles triangle and measure of angle ABD is 30 degrees. The measure of angle CBD is 35 degrees. So which is longer, side AD or side DC? So this is the isosceles triangle, and we all knew that isosceles triangle is a triangle with two equal sides. So these sides are equal. So this is the common side to these two triangles. So basically, by reflexive, this side also is equal. What is asked? Which is longer, AD or DC? So So we will try to figure out. So basically, the side opposite to the larger angle will be the longer side. So side DC is longer than AD. Now, after learning the lesson for today, now it's your time to measure your understanding of the lesson. Write your answer in the comment section below. So find the measures of the lettered angle. Question number 2. Determine if the numbers 5, 12, 13 can be the measures of the length of the sides of the triangle. Problem number 3. Arrange the angles of the triangle in ascending order from least to greatest. Given this figure, refer to the figure below. Which included angle is larger, angle R or angle T? So you can write your answer in the comment section below.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.